So we begin this course, and आप देखेंगे मैंने बहुत सारी सुपरफ्लुअस चीजें भी जो है यहाँ पर लिख रखी हैं, but they all mean something. And तो सबसे पहले तो जो है about the course थोड़ा सा आप जान लें कि ये जो कोर्स है this is conceptual. तो आप ये मत समझिएगा कि इसमें मैथमेटिक्स बहुत ज़्यादा आने वाली है. मैथमेटिक्स बहुत एलिमेंट्री है, ठीक है. There is hardly any mathematics in this. It is all conceptual. You can say, I would say rather 90%, 95% concept, 5% mathematics. That too of very low standard. ठीक है. So you should not be bothered about by the mathematics of this. But then there is a problem that getting the concept is like changing your mind, the way you think, right? So the whole course will go about actually making you aware about how the word goes, at least in the scientific terms, right? And specifically dealing with thermodynamics. But you will have to actually start living it. That is what is required, right? It should become your part. Unless until that happens, it will be a problem. Okay. People fail quite often in this course, despite it being very, very simple. So you should be living it just like when you climb a stairs and you don't have to see, or you walk down or anything when you drive a cycle or car, mobile, you don't feel anything. I mean, you don't have to put a conscious effort. It's all happens subconsciously. So presently this thing should go from your, you can say, the conscious part, it should become your subconscious part also. Okay? Then you will be able to apply it to other systems. So that is one thing. And one more thing about this course is that this is a very, very important course for mechanical engineering. Just a minute. Reason being that, as I told you, it's a fundamental course. So everywhere this will come in. I personally feel that thermal engineering is 50% of mechanical engineering, or if not 50, at least 30, 35% it is there. Because we have other branches of like design, we have manufacturing and industrial, but this is one of the major parts. So you have to take it that seriously. It is going to be, so it will form the basic of the thing, right? And as I told you that when I was doing it, this was my basis, and all that I told you that I did that at the base of it, it was thermodynamics. Of course, there are other subjects also, like mechanics is also there. They are fundamental subjects, but this is one of the fundamentals. Energy and work. Try to understand what is the difference between the two. We need energy to accomplish any work, right? And before you go for doing a work, you need to have an aspiration. And the famous sentence for that shloka for tamsoma jyotirgamaya, it's the same thing. Mrityoma amritam gamaya. And there's one thing, asatoma sadgamaya, right? It's one and same thing which he has brought here. Okay, so there has to be some urge. So we want to do some work and we need energy to do that work. In fact, you would have read the definition of energy. It is defined as the capacity to do work. If you remember your definitions, it is capacity to do work. Energy is called the capacity to. Now then, we need, once we have energy, we need to control the flow of energy. We have to use it, manipulate it. That is also required. And we need to transform energy from one form into another. This is also we need to do. So this is what we are trying to do. We are trying to do work for which we need energy. We want to control the energy. We want to regulate the energy. We want to transform one form of energy into another and use it for the work. And what is the definition of thermodynamics? Thermodynamics is the science of energy. So when you study energy scientifically, means observation, experimentation, and analysis. Not conceptually, but experimentally you want to study. This science of energy is called thermodynamics. So thermodynamics means playing with energy. Now, what all includes is it talks of converting one form of energy into another. That is. And then the second thing is the maximize the output of desire. So what we want is, man is very selfish. He should be. But the problem is he doesn't understand what is in his interest. That is the problem. Serving your own interest is not bad. But the problem is you don't know what is in your interest. So you make all the mistakes. फिर कभी इस पे बात करेंगे. So maximize the output of desired work. So man, what does he want? That कि मुझे काम करना है तो मैं जल्दी से जल्दी कम से कम समय में ज्यादा से ज्यादा काम कैसे कर लूं, कम से कम पैसे लगे. तो हम लोग क्या करते हैं आजकल, वो जोमेटो पे देखते रहते हैं कि कहाँ एक के साथ एक फ्री आएगा. वी वांट टू इकोनोमाइज. ठीक है. फ्राइडे की बजाय अगर ट्यूसडे को जाएंगे खाना खाने तो रेट कम मिलेगा. गुड. There is nothing wrong in it. So we want to maximize the output. Okay. Then it deals with the relation. Now, when you are doing some scientific study of a thing, what will happen? There will be properties of a substance. You cannot study a substance without studying its properties. We know a substance or a thing by its properties, whatever it is. So what the thermodynamics is doing, it is studying the relation between the properties, that these are the properties and what is happening to them. So how the volume is changing, how the temperature is changing, how the work output is changing, efficiency is changing, all these things can be there. And flow of heat and work which causes the change. So what is happening in thermodynamics is, we will come to this thing that thermodynamics involves everything. Everything which is happening in this world is part of thermodynamics. Keep it aside. But traditionally, we talk of heat and work. Now, when heat and work flow into the system or out of the system changes. The properties of the material system changes. This study, that what is happening to the properties of the system or the substance by the flow of heat and work, is called thermodynamics, or it is part of the thermodynamics. So thermodynamics is, you are studying what is thermodynamics, is the science of energy. So you are studying energy, flow of energy, control of energy, movement of you, transformation of one form of energy into another. That is what you are studying scientifically. And when you are doing it scientifically, you talk in terms of properties of the substance, what is happening to the substance by the flow of heat and work. Okay. Now we talk about the first law. Okay. Of course, we will come back to it again. I'm just giving an overview that how this fits into our living. So what is the first law of thermodynamics? We all know that energy can neither be created nor be destroyed. This is the, you can say, most comprehensible or popular form of first law. Although we have a different definition, scientific definition, but conservation of energy or energy can neither be created nor be destroyed. And of course, this statement is, people doubt this now. One thing they know, that mass can be converted to energy and energy can be converted to mass. So these things are no longer valid in that respect. People are thinking in terms of that also, that space can also be converted into energy. We have a concept that space is vacant. Nothing is the space. No. Indian system says space is the fifth element. It's an element. Usme there is earth, water, air, and this fire and space. And Einstein says that space can be bent, it can be elongated. If it is nothing, how can you bend it? How can it? Our rishis already knew it. So people are still confused that energy is conserved or not. There are so many things have come up in last 20, 30 years that everything is almost changed. Right? You know that time can dilate. Very well, you know. And if you do not know, let me tell you that when you send a spaceship or a space satellite, then the watch on the satellite and the watch on the ground are become out of synchronous. And they have to make corrections for that. Otherwise, your missile system, the space satellite system will not land up at proper position. So you have to take into account that the time varies with height, with the gravitation pull. Right? Just like space gets curved, time gets dilated or elongated or contracted, whatever it is. And it is taken into account in scientific experiments. It's not we are not talking about just philosophy or imagination or some fantasy. It is there. People are doing it. Okay. So anyway, that is a separate thing. That was, I was talking about that this law, how much it stands. But one thing is there, howsoever good Einstein is, that time dilates, space bends, and this and that, all that. When we do day-to-day activities, we follow Newton and we never go wrong. So in a classical mechanics, in a classical world, when we are not talking about either subatomic particles or when we are not talking about very big masses, etc. Right? For us, the light travels straight line. For us, there is no time dilation. Right? Space and time are separate. All those things are valid in a limit, right? So what we are doing is in an engineering, that is why the physics and engineering are slightly different. In engineering, you talk about physical things on the earth, what you are doing, how it is useful. Science can be imaginary. What is happening on a star? What is happening inside the black hole? You will never go there. You will never experiment with that. Your day-to-day life will remain like that. But there are big and big scientists who are working on what is happening inside the black hole, what is happening on the surface of the black hole, whether the black hole is following the thermodynamics law or not. All this research is going on. Okay? But day to day, we find that energy is conserved. जो हमारे power plants हैं, those our all this system, electrical system, machinery, air conditioning system, everywhere, automobile system, energy is conserved. Mass doesn't get converted into energy, or at least we don't come to know. It is not perceptible. So, okay. What does it mean actually? If the energy is concerned, what it means is that it is impossible to drive a motorbike without fuel. I always wished that I had a motorbike. Of course, I didn't have the, when I needed the bike, I had not the money for that. So if I had the bike and the fuel free, then I would have gone for a world tour with my girlfriend. But I could not, and he left. Sorry, she left. तो हमारी इच्छा रहती है कि हमारे पास एक ऐसी मोबाइल हो जो फ्यूल ही ना डालना पड़े. But unfortunately, the science says no, energy is conserved. अगर आपको इसको चलाना है तो इसमें फ्यूल डालना पड़ेगा. ठीक है. लोग ये भी चाहते हैं कि एसी उनका बिना बिजली के चल जाए. और यूपी में तो पहले होता था, दैट इज पीपल यूज्ड टू टेल कि एक कट डाल देते थे. वो बहुत जगह होता है. आपने सुना हुआ है कि हाँ. अब now they cannot make an AC which can run without electricity. To at least they can do is bypass the electric meter. हर एक की इच्छा है कि भाई इलेक्ट्रिसिटी के बिना ही जो है मेरी एसी चल जाए, बट पॉसिबल नहीं है. तो व्हाट इट इज टेलिंग अस, it is telling that what you think, there is some restriction on it. You do not have the full freedom. You have to follow the laws of science, and it says the energy is conserved. So what I can do is, you look at this diagram. The world is made up of different processes, right? Any type of process you put, and you can put it here. This is the universe of the process. What the first law is saying, that divide in two parts. What is the two parts? Here the first law is valid, and here the first law is not valid. So the reason or the processes which follow, which do not follow the law of energy, they are imaginary. सपने में उसको fulfill करना. So I used to go on motorbike ride with my girlfriend in my dreams. That is possible. I can go anywhere, even moon. Honeymoon on moon. In dreams, it is possible. In reality, it is not. So what the first law is doing, okay, whatever you think, whatever the process you have made, there are possible, there are impossible. All the processes which are not following law of energy, they are impossible. Okay. Now we come to the second law. What is the second law of thermodynamics is doing? We know that the first law is saying that processes which energy is not conserved are impossible. So it is saying that these processes are possible, these are impossible. But the second law says, wait, I am also there. And he says, second law defines another set of processes which follow the first law, but they are still not feasible. Even when the first law is saying that these processes are possible, second law says no. You divide again it in two parts. And out of that, they are, okay, so let us go to this diagram. So what it has done, second law says, make one more section. So this is, first law is valid, second law is valid. First law is valid, first law not valid, second law is valid. Yeah, first is not valid, second is not valid. And here, first is valid and second is not valid. Out of these, all these three quarters, where any of the law is not valid, is impossible. So the only thing is possible is this. These are impossible processes. All the processes are lying outside this region are not possible. So the second law says that even if the energy is conserved, there is still more to it. And there are processes in which energy is conserved and they are not possible. Now let us talk about, are there such processes? Let's go back. Now what are those processes? So second law is actually giving you the direction of change. That it controls the direction of change. It is saying that it's not that the energy is conserved by नहीं, फर्स्ट लॉ का तो सारे कोई भी एग्जांपल आप ले लो, मैंने बताया ना वो मोबाइक हनीमून नॉट पॉसिबल, नॉट वैलिड है ना. द फर्स्ट लॉ इज सेइंग दैट पेट्रोल नहीं डालोगे तो नहीं जा सकते. हाँ, ये नॉट वैलिड हुआ. वैलिड क्या हुआ? पेट्रोल डालो चलो. Now, what is there any process like that? Okay. Now, spontaneous. This is first process is the spontaneous flow of heat from low temperature to high temperature. Now, you all know that heat flows from high temperature to low temperature. You keep a hot glass of water here, after some time it will come to the room temperature, no problem. Can you ever imagine that heat comes from air and collects in the glass and the water starts becoming hot? It's not a violation of energy. Energy is coming from air, coming into the glass. We are not creating energy. Energy is coming from the glass, around the glass, and getting collected in the glass, and its temperature is rising. Not possible. Okay. You take another this example. In this room, there is air, right? And air is a mixture of what? Carbon dioxide, nitrogen, oxygen, and water vapors, and maybe some other things. Now, if you imagine कि ऐसा हो जाए कि कार्बन डाइऑक्साइड इधर आ जाए, नाइट्रोजन उधर चली जाए और ऑक्सीजन उधर आ जाए और इधर वाले सब मर जाएं, पॉसिबल है क्या? नॉट पॉसिबल. इसमें एनर्जी वायलेशन नहीं हुआ है. It's not energy variation. I am only saying the atoms of the oxygen from here move to that side and collect there. Not possible. आपको करना पड़ेगा. आप इसमें से ऑक्सीजन निकाल सकते हो. You will have to make a machine for that. एयर से हम ऑक्सीजन बनाते हैं, नाइट्रोजन बनाते हैं. That we do, but we do through a long process. ये ऑटोमेटिक नहीं होने वाला. ऑटोमेटिक नहीं होने वाला. इसी तरह से ये सिमिलर एग्जांपल्स हैं. अगर आप देखें कि आपने एक बोर्ड के ऊपर बॉल्स रखी हुई हैं, उनको मिक्स कर दें. पहले तो वो अरेंज थी, फिर उसको आपने हिला दिया, वो मिक्स हो गई. मिक्स होने के बाद व्हाट यू वांट कि वो सेपरेट हो जाएं. हिलाते रहिए, वो सेपरेट कभी नहीं होंगे. मिक्स होने में तो कोई देर नहीं है. दाल चावल है, इसको पकड़ा, चावल को इसमें किया, मिल गया. अब घुमाते रहो और ये कोशिश करो कि वो अलग हो जाए, तो नहीं होगा. ऑन इट्स ओन, चाहे आप ऐसे हिलाओ. एंड दिस इज नॉट अ वायलेशन ऑफ एनर्जी लॉ. फर्स्ट लॉ का वायलेशन नहीं है. दिस इज समथिंग एल्स. सिमिलरली देयर इज समथिंग कॉल्ड रनिंग ऑफ ए पावर. देयर इज एक्चुअली जो है, सारा थर्मोडायनेमिक्स शुरू कहाँ से हुआ? उन्होंने कहा कि भाई हमें एक ऐसा पावर प्लांट बनाना है. एयर इज फुल ऑफ इन्फिनिट एनर्जी, सी इज फुल ऑफ एनर्जी. Why can't we extract energy from air or sea and run our machine? Not possible. Thermodynamics says that you require a hot source and a cold source, and you can take only heat from the hot source, and then you will reject some heat in the cold source, and the difference between them you can convert to work. It's not possible you can take, there is only one source and you take heat from it and convert it to work. नहीं possible नहीं है. So that means there are certain processes which are not violating first law but which violate the second law, and they are not possible. Okay, so this is what the second law says, and this is put up in this diagram, that there are four parts of it, and only one where both the laws are. That is the real zone. Rest all is imaginary. There's only one place, one section of it, which lies 1/4 of this imaginary process. So out of that, which is physical. Rest all is invisible. Either you break first law or you break second law, things will not happen. It has to be imaginary, invisible, dream state, you do whatever. On the ground, in real life, it will not happen. Okay. Then there is one more thing, and I will stop before, just to mention that the second law defines the quality of energy. We always know that energy has so much of energy, joules, but it's not that enough. Energy has a quality also. So if I have a 2 glasses of water, one taken from the drain and one taken from the tap, even when they contain the same amount of water, their quality is not same. One I can drink, other I cannot drink. Same thing applies to energy. Energy, even if you have same energy here, they may not be same. And if their temperatures are different, they are not same. Heat and work are not same, right? So we will discuss more about it, and stop here.